Okay, so algebra. Now, I have got a couple of other algebra videos kicking around, so if your algebra is really bad, you might want to look at those as well, but otherwise this is going to be kind of the summary version, assuming you have some presumed knowledge. So, first of all, it's the language that you need to get your head around. So they generally ask you to do a couple of things. One's to simplify, which means that we're just going to collect and combine what we call like terms, and then process any numeric calculations as well. The other thing they'll ask you to do is to evaluate. If they use the word evaluate, then you're actually sort of answering it. Solve is similar, so they'll generally, you're going to wind up with an answer of x equals or a equals or whatever it is that you're looking for. And expand and simplify sometimes, and sort of bombast and those sorts of things. But let's start with the simplify. So if we were going to simplify an equation, we're going to collect first of all our like terms. Now, terms are like if they have the same pronumeral, which is just your letters, with the same power. So if I'm talking about just, let's say, an A here, then A implicitly has a power of 1, okay? If anything has a power of 0, then anything to the power of 0 is equal to 1, so I could have any number I liked. If I put it to a power of 0, it's always equal to 1, so that's always a bit of a trick question. But a letter without any sort of index implicitly does in fact have a 1, so just bear that in mind. Take this mess off. Okay, so we're looking for letters with the same power. So here I can see I've got a 2a squared to start with, so I'd be looking for any other a squared, and that would be my like terms. So in this particular equation, I've also got a 3a squared, and I've got other a's, but not with a power of 2, and so those would not be like terms. So at the moment, all that I could add would be the 2a squared and the 3a squared. So I'd wind up combining those. So 2 plus 3 gives me 5. So altogether I've got 5 lots of an a squared. Okay, then I'd look for my next like term. So if I change colour here, the next thing I have is an a. And so I'd be looking for other a's with a power of 1 in this case. So I've got that 4a, and I've got this negative a here. So 4a, take away 1a, would give me 3a's. So here I've got overall plus 3a. And then I've got these numbers. Now they are just numbers, and so basically I can just process these as they are. The square root of 9, of course, would be 3. And so I'm left with 3 take 4. So 3 take 4 is negative 1, and that would be my final simplified version of that equation. So all I've done is gathered all the like terms and then processed any of these sort of numbers and things that I can process as well. So that's simplifying. Okay, if I went to my next example, in this case I'm not just adding. In that previous one I was adding up terms. In this case I'm multiplying. When I'm multiplying, what you need to remember is that it doesn't matter what powers. I don't need like terms as such. I can just sort of multiply things together. So start with your numbers. Here I've got a 4 and I've got a 2. So 2 times 4 is 8. So if I deal with the numbers first, I'm going to wind up with an 8. Then I am multiplying all my a's together, but it doesn't matter about their current powers. So a times a squared would give me a to the power of 3, because a on its own is effectively a to the 1, and if I times that by anything else, then generally that rule is that you're adding up whatever your indices are. So in this case I've got a 2 and a 1, which would give me a final index of a power of 3. Then I've got a b as well in here, so my b, and there's no other b, so I'm not needing to actually times that by anything. And I've got a c as well, and there's no other c's to times that with, so it won't change its power. So my final simplified answer would be 8 a to the power of 3 times b times c, and this means 8 times a to the 3 times b times c. Okay, so that'd be our second one. My third one, I've introduced some fractions. So you're going to need to remember a couple of things about fractions. So let's do this one step at a time. First of all, let's do the numerator, being the top bit. So we're going to do the same as we did in the previous question. First, we'd multiply any numbers together. So 12 times the 3 would give me 36. So that's my numbers dealt with. Then I've got an a squared and I've got an a to the power of 3. So as we said before, when we're multiplying numbers with powers, or letters to pronumerals with powers, what we're effectively doing is adding all the powers up. So 2 plus 3 is 5, so I'm going to have a to the 5 here. And if I did that in a longer form for those who aren't good with these sorts of things, a squared means a times a, and I'm multiplying that effectively by a to the 3, which is a times a times a. So altogether, that's where that 5 came from. Altogether, I've got 5 A's. Then I've got to deal with my B's. So I've got 1 B here and 1 B here. So altogether, I would have B squared. And I've got no other letters, so that's all my letters. But I have just noticed that I missed this 4. So I previously went 12 times 3, and that gave me my 36. But I've also got a 4 here. So I now need to go 36 times 4. It doesn't matter which order we multiply things in, but we do need to process that. So I would have altogether had, in fact, 144. So I'll just get rid of that 36. Oops, got rid of too many, that's right. And I'm going to wind up with 144 a to the 5b squared on top. So that's dealt with my 3 numbers. And I've got all my A's and all my B's. Yep. Okay, that's all of that is now going to be over my A to the 4, B to the 6. And so now I can start cancelling out. So the next rule you have to remember, when I'm multiplying pronumerals with indices, I add them. When I'm dividing, I subtract them. Or you can think of them as cancelling out. So if I was looking at these A's at the moment, I've got an A to the 5 and an A to the 4. These 4 A's on the bottom are going to cancel out with 4 of the ones on top. If I'd written just the A's out in full, that A to the 5 means A times A times A times A times A. I've got 5 of them. 1, 2, 3, 4, 5. Over 4 A's. So A times A times A times A is what all that actually means. And so you can see that that A would cancel with that A would cancel with that A would cancel with that A, that one would cancel with that one, which leaves me with just 1A. Don't be fooled here. If you're going to write this, there's at times they won't simplify it quite nicely. It's not that there's nothing under the bottom here, it's A. Technically what I'm left here with is A on 1. Okay, in this case it doesn't actually matter because all I'm going to do is leave 1A on the top. The 144 is going to stay there because I've got no numbers on the bottom to cancel out with. So I'm going to be left with 1A on the top because that bottom one's cancelled out with 4 of those. And then I'll do the same sort of thing with the B. So effectively what I've got is B times B is my B squared over B to the 6, which is B times B times B times B times B times B. That B will cancel with that B will cancel with that B, which leaves me with 4 B's on the bottom. And so basically I'm going to wind up with 144A over those 2 B's are cancelling out with 2 of those, which leaves me B to the 4 on the base. And that would be my final answer there. The rule you would have done in year 12 is basically it's the top index, take away the bottom index. So we had that original 2, take away my 6, which gave me the 4. Gave me a negative 4. And if I've got a negative index, then it means it's underneath the fraction line, which is what we've got going on there. Okay, let's get rid of all this mess here. Okay, let's have a look at the next one. Expand and simplify. So these are kind of our half crab clause. So when we say expand, brackets in maths mean multiply. So what we're really doing here, oopsies, sorry, I didn't want my erase button on. What we're really doing here is going 2 times x and then 2 times the negative 3. So 2 times x gives me 2x. 2 times negative 3 would give me negative 6. Plus, then I'm going to do the same for the next bracket. So it's 4 times x, which would give me 4x. And 4 times negative 2, and they're both positive, so I'm going to wind up with a positive answer. 4 times 2 is 8. That's my expanding part of the process, and then I need to do the second part, which is simplifying. So again here what we're doing is adding like terms. So I've got 2x's here and 4x's here, so they would be considered like terms. They're both x's, both with a power of 1, so I can add them up. 2 plus 4 is 6, so altogether I've got 6x. And then my next like terms are just my numbers. So if you look here, I've also got my numbers. I've got a negative 6 and a positive 8. Don't forget when you're dealing with numbers, they won't always be as nice as this if you've got negatives and positives. The bigger number, the sign on the bigger number will determine the sign of the answer. So here I've effectively got 8 take 6 is 2. Mentally I just do the subtraction, so my answer would have been 2. Sorry, change pen. And because my bigger number is positive, my answer will be positive. And that would be my final expanded and simplified version of that equation. Okay, the next thing we need to consider in this topic is BIMDAS. Now, if I ask people what's BIMDAS, people automatically will parrot off the brackets, indices, multiplication, division, addition, subtraction, and we kind of have that burnt in our brains. But in practice, in every exam, people do really badly at these because they forget to actually apply it. In every maths, BIMDAS applies in maths always, so it's just a given. But very few of your questions will say use BIMDAS to answer this question. They'll just give you an equation like this one here. So this was actually modelled on a previous exam question. They'll give you an equation like this and just ask you to solve it. And it's implicit that you must use BIMDAS, but they won't have used BIMDAS in the wording of the question. So before I move on to there, I'm just going to highlight a couple of things. When we do BIMDAS, we do indeed start with brackets. If there aren't any, we'd carry on. We'd then look for indices. Indices include square roots, okay, because anything that's been square rooted is effectively that number to the power of a half. Or if I said I was doing a cubic root, so a third root, then it would be, so if I said the third root of a, I could rewrite that as a to a power of a third. Or if I wanted the fourth root of a, then that's the same as saying a to the power of a quarter. So anything with a square root sign it is implicitly also an index, so do that step second. When we get to the multiplication and division, what you need to remember is that that's not necessarily, it doesn't mean that we have to do a multiply before we do a divide. We do multiplication and division, they're of equal importance, and we just work on those from left to right. So whatever my equation is, I'm just working left to right. So if I was looking at this equation below, in this case they actually have got the times before they've got the divide, but even if they didn't, I wouldn't need to worry about that. I would still just go left to right on my equation because they're of equal importance. Same with addition and subtraction. You don't have to do an addition before you do a subtraction. You do them in the order in which they appear. They're of equal importance. So let's have a go and actually apply this here. So if I was looking at this equation and I was going to be using BIMDAS, then the first thing I need to do is basically look for brackets, indices and so on. So you can see here I've got no brackets, so I can ignore that step. And the next thing I'd go on to is my indices. Now, in theory, as I say, this square root is treated like an index. So the square root of 16 is 4, so I can automatically sort of replace that bit with a 4. The other index I have here is this 3 to the power of 2. So 3 to the power of 2 means 3 times 3, which is 9, so I can rewrite that with a 9. I'd process that first. The next thing I must do is any multiplication or division. So the next step that I'm going to have to do is basically I'm going to deal with this multiplication and I'm going to deal with this division. And I'm going to do those before I deal with this subtraction and this addition. So the bracket here, 3 times 4 is 12. So this whole part of the equation is being replaced with a 12 effectively. Then this next bracket here, I've put the brackets in. You don't need to put any bracket in. I'm just trying to highlight the bit that you're doing, but you certainly need to process this next. So 36 divided by 9 would be 4. 9 fours are 36. So the equation I'm left with at this point is 4 plus my 12, take away another 4. So obviously my answer here would wind up being 12. But that's the way you need to show it. So first deal with anything, brackets or the indices, then do your multiplications, then treat those numbers as the individual numbers that they are, rewrite it and show your final calculation. Let's look at another one. The next one says evaluate. So evaluate basically means we're going to do any of these substitutions, and if we could solve it, we could solve it. Okay, so in this case I don't think we can, but we'll have a go. So we know that x is equal to -3. Now, this is one of the most common mistakes. The first time we see x is in its squared form. This is super important. So x is -3. So I'm going to, every time I see an x, I'm going to treat it as if it's in a bracket. So this is -3 squared. -3 squared is going to give me a positive 9, because basically -3 squared means -3 times -3, which would give me a negative times a negative is a positive 9. This is very different to if you just write down -3 squared, and if you put that into your calculator, what your calculator is going to tell you is a -9, because it's doing BIMDAS. It's going to first deal with this index before it deals with that subtraction. So it's going to go, well, 3 squared is 9, and then it's going to take it away, which will give me the -9. So automatically, if you put something into your calculator in that form without using this bracket around it first, your calculator itself, you're going to think you've done the right thing, but you're going to wind up with the wrong answer. So you need to be super careful. If I, and we've got one underneath here, if I said negative y squared, well, I'm going to then take away whatever. I'll deal with that when I get to it perhaps, but yeah, watch that. So all I'm really saying here is that there's a big difference between saying negative 3 squared and negative 3 is my value squared, because the first one would give me a negative 9, the second one would give me a positive 9. So in this case we are substituting this value, so it's this value in particular that we are squaring. So this first one is going to give me a negative 9. I'm going to carry on with the next bit. I'll deal with that one at a time. Take away 2 times x. So again, every time I see an x, I'm going to bracket it and put in that substitution, which in this case is that negative 3 over 4y. So I'm going to replace y with whatever y was. Y was the negative 2, so I'm replacing the y with the negative 2. Take away, I'm simply copying from that formula, y squared. Y again is a negative 2. And so this is what I'm going to wind up with here. Now I'm going to now break this down again. So negative 3 squared, the first part of that equation will give me a positive 9. And then here I've got a negative times a negative. So negative times a negative is going to give me a positive answer. 2 times 3 is 6. So all up so far I've got 9 plus 6 on the top. So that's going to give me a 15 on the top. And then I'll deal with this bottom bit. So the first bit of it is saying 2 times negative, bracket means times of course, so 4 times negative 2. So that's going to give me a negative 8. And then I'm going to take away the negative 2 squared. Negative 2 squared is negative 2 times negative 2, so that would give me a positive 4. And so I'm winding up with negative 8, take negative 4. Now if you've got two negatives, again, people tend to be a bit sloppy with these. If your signs are the same, then your answer's also going to be negative, but mentally you can just add them. So 8 plus 4 would give me 12. So I'm going to wind up with a final answer of negative 15 on 12. That won't simplify, and so because there's no numbers that I can put into 15 and 12, so I just leave that as a final answer. The only other thing that I want to highlight here, and again it's just in the interest of your general algebra skills because they do tend to be a little bit lacking in these classes, is that 15 on negative 12 is the way I've written it, would be exactly the same as if I said negative 15 on a positive 12, means exactly the same, or I might put the negative symbol in the middle and put it like that. So don't get bogged down on where your negative is, in this case it just made logical sense because it was on the 12th to leave it there. But it would mean the same here. So if later on you have to be rearranging equations, you can choose where you put that negative sign. Don't introduce any new ones or anything, but the placement of it doesn't actually matter. So if you have to rearrange things later, just keep that in mind. Okay, the next thing we have to deal with is substitution. Substitution is when they give you an equation and they tell you what some of the letters within that equation are, what numerical value they're going to take. And so you're literally going to substitute those in. And provided you have only one letter left, then you can solve for that equation. So if we did this one, okay, so z is equal to 2x times y squared, subtract 3 times y. So here they've told me what x is and they've told me what y is, and we're just trying to find z. So z is going to be equal to 2 times x, x they've told me is 1.1, times y squared, y is 0.2. And we're going to need to square that. So again, every time I see a pronumeral, I just put it in a bracket. This is much safer in this level of maths than saying 2 times 1.1 times 0.2 squared. It means the same. However, a lot of people's handwriting is not great, and when examiners read this, these time signs often look like an X. And so be super careful, and if you can, avoid using a time sign. Mostly at this level of maths, we don't really use them. We tend to use brackets, or we write letters next to each other like this, and it's implicit that we are multiplying. So that is my preferred way for you to show that. And then if I finish that equation, we're then going to take away 3 times y, and y is 0.2. So the next thing I'm going to say to you is that you need to be able to do this mentally. You need to be able to do all of what I've done so far mentally. For this whole video, so make sure you practice doing it. Don't become too reliant on your calculator. So let's do this. We're going to follow BIMDAS again. So even though again we've moved on and we're not implicitly doing BIMDAS is always a thing. So first deal with those things. So the first thing we're going to deal with here, and the brackets haven't got any functions within them, so we don't really need to do anything with the brackets. But the first thing we do have is a power. So I'm going to deal with that one first. 0.2 squared. Now, people tend to look at that and go, oh my God, I can't, possibly be multiplying decimals. It's as easy as going 2 times 2 is 4, and then how many decimal places do I expect? Well, if I've got, so this is effectively 0.2 times 0.2, if it's 0.2 squared. So as I say, 2 times 2 is 4. If I have 2 decimal places, so here I have 1 decimal and this number 1 decimal here, so all up I have 2 decimal places, so my answer will include 2 decimal places. At the moment, I don't have any, so I know that this answer is going to wind up being like that. So I needed to create 2 decimals. So this, when it's processed, would be a 0.4. So I'm going to rewrite that again with the brackets so that we've got that in there. Now, and then I'll leave the rest of the equation so far as it is. Now, the next thing I'm going to say is it doesn't matter which order we multiply things. So, do whatever's going to be easier. 2 times 4 is the same as 4 times 2. The order doesn't matter. I've got 3 numbers now to multiply, and which way I start won't matter at all. So what I'm going to do is I think it's easiest to go 2 times because 1.1 I'm going to treat as an 11 when I multiply, and the 11 times table is nice and easy. Okay, so this is why I'm doing this. 2 times 4 is also easy. But again, people's mental maths tends to be pretty bad. So 2 times 0.04, hopefully you'll realise is 0.08. Mentally, all I've done is 2 times 4 is the 8, and I had 2 decimal places in those multiplications, so my answer has to have 2 decimal places. When I then go to multiply that by the 1.1, so now I'm going, basically mentally what I'm doing is 8 times 11. 8 times 11 is 88. But what I've got here is 1, 2, 3 decimal places, so my answer needs to have 3 decimal places. And so I'm going to wind up with 0.008 as my answer there. Hopefully that wouldn't be too stressful for you mentally. Take away 3 times 0.2. So again, mentally, 2 3s are 6, and there was 1 decimal place, so my answer will have that 1 decimal place. And now I need to do that subtraction. And again, in practice, I find that people's maths is actually much worse than we think. And the people try to generally get the more complicated stuff in this course, and it's their basic sort of arithmetic that lets them down. So let's do this. So 0.088, take away 0.6. The first thing you must be careful about is that you must keep all your units in nice, neat columns so that, your place values are sort of being used correctly. So let's do this. So this is effectively reading 8 take 0 is 8. 8 take 0, because if there's nothing there, we treat it as a 0. 0 take 6, I of course can't do. And so I'm going to wind up with a negative answer here. And that's going to be a little bit tricky for a lot of people. People sort of get to this point and go, well, there's nothing to borrow from. What am I going to do? So at this point, I'd actually probably say it's probably easier to do this in reverse, but then put the negative sign on it. So let's have a go with this. So I'm going to have 0.6 take away 0.088. Sorry, what I didn't need is that line there. I want the line. Oh, goodness me, I'm going to rewrite this neater over the side here. So 0.6 take away 0.088. Now, if we were going to do this, and again, I might put those zeros in there for people. So effectively what's going on here is I'm going 0 take 8, which I can't do. So I'd need to start borrowing numbers. I can't borrow any from this next column because there's nothing there. So I'm going to borrow from all the way over here. Now, when I do this, so I'm borrowing 1 from there, it always has to go to the next place. So this would become a 10, and then I can borrow from that, which would make it a 9. And I'm left with 10 take 8 is 2. And then 9 take 8 is 1. And then the 5 take 0 is 0. Sorry, goodness me. This is what goes wrong in these exams. You can see why you guys get it wrong. 5 take 0 is 5. Okay, sorry, 9 take 8 was 1. That was still there. And then 0 take 0 is still 0. Now, there's my answer, but what we have to remember is that it was actually the 0.6 that was negative. So my solution here is actually going to be a negative. And that would be my final answer for my question over here. So, keep a little eye on this. It's simple in theory. In practice, as I say, it's the mental mathematics that tend to set people wrong. And so be super careful. You might want to revisit some of those skills. A lot of you probably haven't really actually used them since primary school. So as you're going through your questions in the book, do put your calculators away, practice doing these things mentally to get those little skills, particularly dealing with decimals and your old school multiplications and divisions. The other multiplication trick that I'd urge you to try here is perhaps the Arabic. And I will deviate to this so it seems long-winded, but a lot of people prefer to have one system only. Instead of doing this process here, a lot of people get really confused about how many decimals they got and what's going on. The other method would have been the Arabic, and I've got a whole video on how to do the Arabic, so this will just be a very quick recap. I'll change colours so you can see what I'm doing. I'll do it in brown over here. If I did the Arabic, here I would have been going 1.1 times 0.08, and there's heaps of zeros, so this is only going to take you 2 minutes. Once you've got your numbers, you're essentially putting your lines, ignore your decimals, okay, don't create boxes around them because you're going to be artificially introducing place values. So you put your box around all your numbers, and then you're halving each box with a line. And what this creates, oopsies, I'll back that one up and do it neater. What this is creating is these columns. You can see the columns that are forming there, and that's where we're going to wind up adding into. So let's process this. I'll change colour. So 0 times 1 is 0. If it's a single digit, it goes in that bottom corner. 0 times 1 is 0. And then again, I've got 0 times 1 is 0. 0 times 1 is 0. So, you know, it's simple. 8 times 1 is 8. Single digit number, so it goes in the bottom corner. 8 times 1 is 8 again. If I'd had a double digit number, then my other digit would go up in this top up here. Then what we're doing is adding up in these columns. So my first column will add up to just an 8. My next column is down here, so 8 plus 0 is again 8. My next column, 0 plus 0, is going to give me a 0. And the final column is just that 0, so there's nothing to even add here. And as a last step, you're adding up how many decimal places you had. So I had 1 decimal at the top. I had these 2 decimals here, so all up I've got 3 decimal places. So I'm literally going 1, 2, 3. That's where my decimal has to go, which would give me the 0.88, which is what we, of course, already had over here. So that's your other method, and I've really made quite a chook's breakfast of this working out now. But that's your other method that you can use if you're really not confident with sort of playing around with your decimal places and things. Now, the next thing that you need to be able to do, and the final thing you need to be able to do, is to do some of your algebra in ClassPad. And ClassPad, again, it has a magic button for almost everything. In this case, in Maths 3, there's a little button that literally looks like just a line, and that will allow you to substitute effectively into a formula. So you effectively will just type a formula into your ClassPad. After your formula, you'd put this line, and you would use this set of curly brackets to tell it what the values are of each of your pronumerals. If I was using an x, I'd then say x is equal to, whatever it is, a comma, then my next variable y is equal to whatever that is, and it would substitute it into the equation. So we'll do an example in a moment. But I more often than not don't even use that button. There's another option where you can create variables. You'll say x is equal and you create a variable. I think that's probably a bit dangerous because often you forget you've created them and your calculator remembers it. And so then you might accidentally use another equation that also has an x, and your calculator is assuming x is a preset number and it's not. So I don't encourage that one. What I do encourage, and what I absolutely say you absolutely must be able to use, is your highlight interactive advanced solve. So if you're just in your main screen and you substitute all your numbers into a formula, type the equation out, you can then highlight your equation, go into interactive on the top right hand corner, and I'll show you pictures of this, go into advanced and then solve, and it will solve it for you. Or you can use that same function to rearrange a formula. So often they'll give you a formula, and the thing that you're actually looking for is somewhere in the middle of that formula, and they'll say rearrange it to make that other number, the other pronumeral, the subject. And you can use that same function, type it in as you see it, go highlight, interactive, advanced solve, whichever letter you do want, and it will rearrange it for you. So let's have a go at this. So if I said, so for example, let's make A the subject of this equation here. So I've got B is equal to 2A plus 3C over 4AC. Now that would be a nightmare for most of you to rearrange mentally. So if you're in the calculator section, you would quite literally type, and I've shown you the screens here, So you'd quite literally type the formula in exactly as you see it, and then you'd run your cursor over it and highlight it. So I've done that in this next window. I've highlighted it, and then I go into that interactive, which is in the top right. You would then highlight it, or click on advanced, which I've done in this next screen. That will open up this next box, and you'll click on solve. Now, when you do that, it's going to come up with this window, and what you'll note is that it's automatically defaults to an X regardless of what letters you've used. So you at this point would need to overwrite that and just delete that, and we wanted to solve for A, so we would type an A into there and then just click on that OK button. The only other thing I'm going to mention at this point is that when you are putting these letters in, you need to use the variable tab I've shown in this next screen. So this A must come from the var tab. There's two tabs which will give you the alphabet, var and ABC. And when you, for the uninitiated, you'll type it in, they'll both look identical. But if you've used ABC, the class pad just treats it as text, not as an actual variable. So if you want it to be something that can be solved, it must be the var tab that you use. And I think they show up as slightly more italics than what they will if you use the other buttons. The other safe buttons to use is the X, Y, Z. That's just hard keys on your class pad. They are also variable, so that's safe if it's an X, Y, Z that you're using. But for any other letter, the var tab is what you need. And as I say, you then just click on your solve and the class pad. In this case, we were asking it to solve, but we've got too many variables for it to actually solve and no information about them. So what it's actually done is just rearrange it, with A being the subject of the formula, and that would be your final answer there. So make sure you make friends with your class pad, because if you're in the calculator section, then you're allowed to use it. Let's do another example. So in this example, I'm going to show you how to use the other magic buttons that we were talking about. So here, and this was from the club review questions, here we were given a formula. So we've got negative b, take the square root of b squared, negative 4ac over 2a, and that's actually the quadratic formula. And then they've told us solve that for when a is equal to 25, b is equal to 395, and c is equal to negative 32. So you could, of course, just substitute these values into your calculator. You could just type this out. I could replace my A every time I see an A. I could just type in a 25 with a bracket. When I see the C, I could just type that in as a negative 32 and so on. So I could certainly do that, okay? And I could replace, and again, I've got another B over here and so on. I can replace all those things and do a solve in the conventional sort of way. That's certainly a possibility, and use highlight interactive advanced solve if I'm solving for a letter that's not on the left. But this other button I will show you. So far what we're doing is we are just typing in the formula exactly as we were given it, and then we were tapping on this symbol here, which is in Maths 3. So if you went to Maths 3, and you'll see it just looks like a vertical line, and so you've typed in your formula. That second line that you're seeing here is actually just the cursor on the class pad. So I've put that in, and then I've hit that little vertical line button over here. And after that vertical line, so you can see it better here, there's my vertical line, I then need to tap on the curly brackets, which is underneath that, and tell it what my values are. So here I've told it that I was told in the equation what my A, B and C were equal to. In between each of my pronumerals, you can see we've just put a comma, and then you literally just hit your blue XE button, your equals button, and that will spit out the answer for you. So in this case, it was negative 16.99. So that function is available to you, and as I say, if you're in a calculator section, then feel free to use it. Okay, I hope that